Rodrigo, are you with us?
I'm here. Can you hear me?
Yes, I can hear you very well. So
Okay.
I'd like to introduce to you our next speaker, Rodrigo Liang. Rodrigo is CEO and co-founder of SambaNova Systems. Prior to joining SambaNova, Rodrigo was responsible for Spark processor and ASIC development at Oracle. He led the engineering organization responsible for the design of state-of-the-art processors and ASICs for Oracle's enterprise servers. The title of his presentation today, AI Innovation in the Foundation Model Era. So, ladies and gentlemen, please help me to welcome Rodrigo Liang.
Thank you, William. Hopefully you can hear me okay. And let me share my slide here. Okay, can see this okay?
Yes.
Perfect. So yeah, really thank you very much for having me back and talking about AI. It's a really exciting time for our industry as semiconductors are back. You see it coming back with the fury with the arrival of AI and machine learning driving a lot of the innovation at the chip level. And so it's an exciting time for our industry. Now we're at the cusp of another big transition for our industry, which is moving into this era of foundation models. And so I want to talk about that today. And now I'll give you a little bit about what SambaNova is doing in this space. And so just real briefly, if you look at kind of what's happened over the last a few decades here, in the 2000s, we spent a lot of time really thinking about what we call today traditional or legacy machine learning. Really a mix between big data analytics with some decision trees and things like that. Moving over into the last of 5-10 years, which was around deep learning. Right, this is where all the excitement around large neural nets and language models, vision models. It's when we started. Where I started our company around this as well in 2017. But now here we are in the 2020s, making yet another transition towards foundation models. And this is something that universities, including Stanford and many other universities in the country, are starting to think about. How do we actually create the next generation of models that allows full benefit of all the data you have to be able to create production quality models that you can actually make use and make big decisions for enterprises. So I want to dive in a little bit more into that. So if you look at foundation models today, what is that? Okay, in a typical company, this is every company on the planet, large and small, you have more or less this same setup for how AI is going to play into your business. You have sources of data on one side, that's your emails, your voice transcripts, contracts, images, you have social media inputs, you have 3D data, a variety of things that you accumulate for your data. This is what's most valuable to many of the companies. Many of the companies represented here today take a lot of pride in protecting that data for their customers and organizing that data for their customers, making sure that is current and secure. On the other side of your business is you have tasks or business practices that you have. You're translating, you're answering questions for your business, you're trying to figure out how to extract information out of that data so you can make business decisions. And so in the world today, right, what's happening is the system is not complex enough for you to ingest all the data you have on the left in order to make the best decisions for all the functions on the right. You just don't, the systems aren't good enough for that today. And so what you're seeing many companies do, and you see some of the largest companies in the world already advancing in that area, is you take each of those tasks on the far right, you create a model that's specific for that task. And then you go to the left and you do a lot of data curation to try to pick out the data that's appropriate to feed that task. And so over time, what you end up having in a corporation is hundreds, if not thousands, of small individual models that power these individual tasks. Well, the problem with that is over time, you have too many models you have to manage, you have a hard time actually being able to keep track of them, and then also being able to actually think about how to make sure that you can have transparency and be able to actually pass audit. Excuse me. So what you really need in between is a single model, right? This is what we're calling foundation models. They're huge in scale. They're able to be they're able to ingest all the data that you have into one large model, is able to actually train and do in-context learning. This is where your data and the task are all now starting to layer over each other, and you're able to learn against that. And then you can reduce these thousands of small models that you're running.
Rodrigo, can you hear me? We maybe is it myself, or I cannot hear you. Rodrigo, are you still there?
I think we lost both audio and video.
So actually, I can hear you. Is it just Rodrigo, or is is a Zoom problem in general?
No, I think Rodrigo lost the connection.
Yeah, I think lost.
Yeah, I saw Rodrigo. We lost Rodrigo. Yeah.
So Zibing, can you call him to see?
Yeah,
if,
I have his number, so let me hold on.
Yeah, I know he's in the hotel room. Maybe the hotel Wi-Fi is down or something. So let's just give him a couple minutes. If there's a prolonged problem, we can shuffle the schedule a little bit.
Hello, William. I just called Rodrigo, and his computer comes, and he's coming back.
I'm sorry, I heard. I cannot hear you 100%. You say he's coming back.
Yeah, he's coming back. His computer hangs, actually.
I'm sorry, Zibing, I cannot hear you very well.
Can you hear me? Hold on. Hello, William. Now
Yes.
it's good.
Yeah,
So
no,
yeah, I think his computer hangs. He will call back. Yeah.
Oh,
Just
I'm back.
1
I'm
minute.
back. Can you hear me? Hello?
Yes, Rodrigo,
Oh,
welcome
yeah.
back.
We can hear you now.
Murphy's law, right? Whenever you are doing a presentation, that's when the system is going to hang, right? So
Yeah.
No problem. All our audience stay put and waiting for you. So, we're moving right along.
okay, sounds good. So let me get my presentation back on. Hopefully you can all see it here. But my apologies for the system hanging on this. So while I'm bringing the slides set back up, and so I can share it. Here it is. So let me do this. Share screen. Okay, can you see this okay now?
Yes, very nice.
Okay, good.
If you can put in the presentation mode, that would be great.
Yeah, so I'm just going to go through. So so that's kind of what foundation models are. Is basically our ability to actually now reduce thousands of small models into one single one that you can query against, and self-learning. It's in context learning, and so this is where you're going to start seeing businesses really look for these 100 million plus opportunities on driving business value. Take problems that are of a certain size and be able to really use the AI to drive efficiency, drive growth, drive changes in the business process in order to be able to get business value, right? And one of the challenges you've seen with AI is that there's a lot of innovation around models, a lot of innovation around creating higher accuracy, but getting them into production has been hard. And so here's the next wave: how do you get AI models into production? And that's really what we're focusing on. Okay, so trend-wise, if you look at kind of where we've been, 2018, you get models that are in this kind of 90 to 100 million parameters. As you've gone into BERT to GPT-2, you start getting into the billion parameters. Now you're in the age of foundation models, 175 billion parameter GPT-3, which many people look at that and say, hey, that's pretty big. Well, until you see the 530 billion and trillion parameter models are coming very, very soon. And these are incredibly complex systems that you have to deploy. And so the challenges that most companies face is, one, the model size itself, right? I mean, this is the type of model that you require 1,000 GPUs gained up to run with all sorts of interconnect, all sorts of power that you have to allocate for racks and racks of servers. So just operating in the model itself, the amount of data that you have to store and parameters that you have to store is incredible. And so that's one. The model is also very complex. If you don't actually map it correctly, if you don't actually have the model operating correctly, you don't get the right result, right? And so this is where now you see this rush to hire more and more data scientists. They're hard to find, they're really expensive to get, they really need to understand deep learning really, really well. And that's one of the challenges that our industry has. And then third, training time. It's very rare in our industry where any application takes a week, 2 weeks to run. These models are taking 30 days, 60 days to run in order to train a model. And so now you're starting to enter this world where the training time is really cumbersome. And so we're going to have to, as an industry, figure out how to, again, attack performance and time for training as one of the key issues in order to actually make the technology continue to grow the way it needs to. Okay, so I mean, here's another example from IDC where they talk about organizations really thinking about AI innovation being driven by foundation models, right? That it is one of those things where you have to figure out how to take advantage of it, and requires investing in every single layer of the stack, from the chips to the system to software, in order for you to actually get these models in a way that's production ready for you to use to get benefits in your business. Okay, so these foundation models, they continue to cut across industry. At SambaNova, we really think about this in 4 major classes of areas: natural language processing, that's your speech, your text; high resolution computer vision, this is things beyond what you can take on your phones. These are your high resolution images from satellites to medical imaging to a variety of other things there. Large recommendation models. And so recommendation powers our economies today, whether that's online retail to ads on social media to share riding applications, Uber and Lyft. And, so that's our economy is powered by that. And you need all of that data in order to provide the best recommendation to your customers. And then ultimately AI for science. And so you're going to see these foundation models really apply to a broad range of things. We think that these are the top 4 areas that you'll continue to see the models be most focused on. Okay, and so the promise of digital transformation. This is what people care about. Despite the fact that companies like ours really focus on models and growing the parameter count, growing the accuracy, really what most people want is they have a bunch of data and we want to get insights, right? And so your promise of digital transformation is, what is the infrastructure that allows you to most efficiently go from data over to insights? And that's really kind of where the focus of companies are. And so you look at today, 80+% of your data in your company today is unstructured. Okay, as much data as we have in graphs and tabular and your databases, most of it is in emails and social media feeds and contracts, transcripts, invoice recordings. These are all things that today are incredibly valuable to you, but they're trapped, right? You actually have no idea what it says in aggregate. You can search for any one email, you can search for any one phrase, but in aggregate, right? It's not easy for you to access and find out what do my customers care about this week? What do they care about yesterday, right? And so that's really the focus that we want to put into our business over the next decade. Thinking about how to take advantage of all the technology we have to unlock this unstructured data so you can make better business decisions going forward. Okay, and so we believe that you need to innovate at every layer of the stack. Here at this conference, we're very much in the silicon side, whether that's in computing, whether that's in storage and networking, interconnect. You're going to find that all of those things are going to get pushed to the limit more and more and more. You're going to have high performance, high scalability, higher efficiency, better power, right? You're going to see software improvements need to be significantly higher in order to integrate this complexity in a way that does not require the user, the programmer, to actually understand the topologies of the hardware, right? You need to abstract all that away. Otherwise, the programming and the software development comes to a halt. And so the sophistication of software, most of you who are in chip companies, you already see it today probably, that your software division is significantly bigger than you expected, right? And so that's going to be true. Systems, as we see people put these things together into more and more complex systems. They need to reduce the total infrastructure complexity. Ganging up thousands of chips is not sustainable, right? It's where we are today, but it's not sustainable. We're going to have to figure out whether that's multi-chip modules, whether that's 2.5D 3D structures, whether that's different types of packaging techniques. You're going to have to think about how to create more dense and simpler systems to deploy into these data centers so that you do not actually have to incur all of the complexity at the data center level. And then finally, to tackle the expertise problem, you're going to need to think about a service, right? That a lot of this knowledge that is required to deploy these complex foundation models are incredibly difficult to deploy, and you're going to run into a skill set problem in industry to find enough machine learning people to actually be able to deploy a GPT-3 or a PaLM model, because it's just incredibly difficult to get it right? So that's kind of what we believe. So real briefly, because of my tech problem, we're short on time. So just give you the quick summary of who we are. SambaNova. I founded this company back in 2017, really thinking about how to tackle the problems that I just described. We're today in 15 countries. We're headquartered out of Palo Alto. We're Series D private company. We raised 1.1 billion in venture capital at a 5 billion valuation, and we're today about a little over 500 people, almost 600 people, and we build these systems. We build our own processors. We call them the reconfigurable data flow chips, and I'll talk a little bit about that. Really focusing on foundation models and deploying them as a subscription model to our clients in order to take advantage of the AI technologies in production. Okay. So I'm just skip through just in the interest of time. So really with SambaNova, we focus on two consumption models. They're based off of the same technology. The silicon is the same. The software stack is the same. Again, abstracting the need to understand the hardware structures in order to actually program machine learning. And so we tie into very high level software, and then the data scale system that then tightly integrate all of that silicon technology into the simplest way to actually deploy, so that as a customer, you just see these units in terms of racks, right? And you can buy it, in these systems that we call data scale, which is integrated AI systems that you can just roll in and run the foundation models that you actually build and maintain. Or if you don't have the expertise, then you do the same, but SambaNova will do it as a service, and we'll pre-train these models for you and deploy those models on your behalf and maintain them on your behalf. Okay. So since this is a chip conference, I'll talk about the chip itself. What we do is a processor that we built. It's a data flow processor, and if you're interested, you can look up data flow. Stanford has done a lot of research and papers on this subject and why data flow is very valuable for machine learning and AI. And so we are very proud of the data flow processor we've built up. It's today the shipping one is 7 nanometer TSMC chip with 86 billion transistors in them. It's here's an important thing: as these parameter counts grow, you need a lot of memory. So per chip, we actually have 640 megabytes of on-chip SRAM. a terabyte of direct attach memory per chip. And so if you're in the chip technologies, whether that's on chip or off chip technologies, please give me faster, more efficient, lower cost bits, because we will consume all of it. We will consume as much as you give us high performance interconnect at a very, very dense footprint. We will use all of that, right? And so nearly 700 teraflops of BFloat 16 is the standard there, and we run a broad range of models there, but really targeted around being able to create very high, large-scale foundation models. Okay, and so one of the things that you see with the parameter counts, obviously in our space in AI, NVIDIA is the standard for many of the AI applications, and they've done a tremendous job actually creating infrastructure that allows people to develop models and create a broad range of models. In the world of foundation models, we think that the parameter counts are growing, the model sizes are growing. You need memory. You need a lot of memory. And so we would, our view of it is you need order of magnitude increase in memory in order to actually create these really dense systems that allow you to run these foundation models. So that's what we've done, and we'll continue to push the envelope on that. On the software side, you need to think about kind of, the native support of a bunch of these different types of applications, including Kubernetes, right? And so one of the things that we talk to people about, it's not good enough to have the host be the proxy for you as a part of the system. AI will become the large computational workload in data centers. And so you need to have native Kubernetes support. And so we invest a lot into that, and tying that into the chip is a challenging thing, but an important thing. And so we can talk to people more about, well, how we've done that. And ultimately racking them up together into really, really, really dense, very well networked, low latency systems that allow our customers to plug in these large machines and then be up and running in minutes, right? And so that's really how we've done this technology. And the end result of doing all of this, and again, people look at these existing systems as the standard for a lot of the training, and by doing it this way for this class of model, these foundation models, even this one is not even as big as kind of the ones that I talked about, 13 billion GPT model, you're able to kind of get some big gains in performance off of a system that's already really good. Right, an A100 system from there is a really good system that runs a bunch of things, and we're able to then, with this focus, able to get significant performance advantage. And you take that performance in terms of power too. I know people have been talking about the fact that power efficiency is really important as its data centers grow, and so you can get significant more power advantage. So I'll just skip ahead. Probably the most important slide in all of this is machine learning is hard. Machine learning, in order to hire the people, train the people, get the infrastructure in place, get the model trained correctly, actually then get the production and inference part correct. Harvard Business Review will tell you that it could take as much as 18 months, right? The subscription piece allows people to actually be able to get up and running 3.5 weeks. That's something that I think all of us in our industry should think about. How do we actually shorten the time to value for our customers, right? Because the longer the customer has to wait for value, the less they're willing to pay. And so I think we, as an industry, we have to think about how do we actually get the customer better value at a faster time. And finally, this will be my last slide here. Really for us in the silicon side, to start thinking about how do we go up the stack, not just in silicon and software and system, but the higher the level of integration, it's an exponential customer value, right? And you want to think about this as an industry. How can we provide more integration for our customers, because the customer value becomes better, and then it feeds into our ability to continue to innovate and invest in silicon. So my apologies for the tech problems that we had, but I wanted to at least go through the slides quickly to give you a feel for what the industry is doing on the AI side, and hopefully this was helpful.
Wow, thank you, Rodrigo. You didn't miss a big beat. It's truly impressive. $1 billion raise, $5 billion in valuation, 100 kilometers of wire in the chip. It's just truly amazing, and we are very honored to have you here with us today. I will save the more technical questions in the chat room later, but just real quick. Nowadays, a lot of companies are pushing AI to the edge. Now, I know a lot of that is in the training, the hard work is in the cloud, in the data center. But like some of the speakers earlier talk about, from cloud to the edge, if they push AI to the edge, do you see SambaNova expanding to the edge space, right? Automotive, consumer, IoT, etc. And if not, what's your view? Who may be the winners of the edge space as the segment consolidates?
Well, the two things that you're going to see, right? You're going to see hardware platforms from deep data center all the way to the edge of the data center to the low power edge, and then you're going to see these models also have the same thing. The software models that are trained in a data center, and you have to try to figure out how to then distill it down to, say, a phone, right? And so you're going to see both of those things. Our view of it is everybody's going to want the highest accuracy model. So you're going to train that model in the data center, and you're going to very systematically distill that to whatever that target is. It could be an ARM core, a CPU core, a GPU core, right? You can put it in, in whatever target you have. So that part, I think, is standard. You're going to have highest accuracy trained in a data center and then pushed into whatever vehicle. At the lowest, for SambaNova, really our value is in creating these large models because the hard problems that enterprises have to tackle. And so for the most part, you're going to see us focus on large scale enterprise problems where, you have billions and billions of parameters where you need large models to actually solve the problem. As you go to the edge, I think you're going to find them to be more target specific. Right? You look at the phones and you already see the major phone players create their own models and embed them into the chips with then taking the models that were trained in the data center and push them into the edge. And so I think that model is going to exist. And I think the major players will have their own hardware there. As you go into other devices, then yeah, I think you're going to see a whole host of players. And this is an area where, those of you who are out there kind of, thinking about being entrepreneurs and doing edge inferencing type of plays, it's a great play. This is early days. The inference play on the edge is going to segment into many industries and many layers. And so if you have a great idea on how to create low power, low latency, and you're able to actually then deploy them quickly, I think that's very valuable. The most important thing though, that I actually encourage everybody to think about is be able to digest models as they change. Do not harden one model because the models are changing too fast. So think about what the architecture is as an inference play and be able to take models that are trained somewhere else and then ingest them into your hardware so you can stay current on the model side.
I think that's the key. And thank you for that. That's, I think just about every week, if not every day, there's something new coming out, right? If not the entire model, some layers within the model and new operators and so on and so forth.
Yeah, it's going to be an incredible opportunity. I think our industry, our semiconductor industry is going to be in great shape. That's going to power more innovations in networking and IOs and storage and SRAM cells and DRAM cells and flash. It's going to power innovation everywhere. So exciting times for everybody in the next 5 to 10 years. So go out there and, it's been a long time coming. And so excited to see everybody innovating out there.